Previously, we looked at integrating functions that were standard integrals. In this section, we'll look at integrating functions that are non-standard, such as the following. Now, to integrate functions like this, we use a method of substitution, and one of the most common is algebraic substitution. And in this type of substitution, we let the original function equals u, where u is a standard integral, and then we integrate with respect to u. And once we integrate, we return the integral back to a function of x. So let's have a look at a question using substitution. In this question, we're asked to integrate the following function. Now, as we can see, this isn't a standard integral. And if we let u equal to 4x squared minus 2, we could differentiate u with respect to x to give 8x. And if we cross multiply, we get du is equal to 8 times x dx. Now in the original integral, we could take out 8x dx and replace it by du. And substitute u for 4x squared minus 2, the integral now becomes u to the power of 4 times du. And if we integrate u to the power of 4, we add 1 to the power and divide by the new power, which gives u to the power of 5 over 5 plus a constant. And u is 4x squared minus 2, so resubstituting that back in, we get 4x squared minus 2 to the power of 5 over 5 plus a constant. So here's a question that you could try. Integrate the following function with respect to x, and once again use substitution. So we could rewrite the integral by taking 3 outside to give the following. And if we let u equals x to the power of 5 minus 2, du dx becomes 5 times x to the power of 4. Cross multiplying gives du is equal to 5x to the power of 4 times dx. And if we divide both sides by 5, we get 1 over 5 du is equal to x to the power of 4 times dx. So substituting u for x to the power of 5 minus 2 and replacing x to the power of 4 times dx with 1 over 5 times du, we get the following. And integrating u squared, we get u to the power of 3 over 3. And if we resubstitute x to the power of 5 minus 2 for u, we get the following expression. And as you can see, the 3's cancel and we're left with x to the power of 5 minus 2 cubed over 5 plus c. So now let's have a look at integrating a trigonometric function using substitution. So here we could let u equal to 4x plus 2. And if we differentiate u with respect to x, we get du dx is equal to 4. And if we cross multiply, we could write dx is equal to du divided by 4. So substituting u for 4x plus 2 and du over 4 for dx gives us the following. 2 into 4 goes twice, and take the half outside the integral sign, we get the following. And if we integrate cos of u, we get sine of u. So resubstituting 4x plus 2 for u gives us a final answer of a half times sine of 4x plus 2 plus a constant. So here's a problem that you could try. And finally, we'll do one more question where we're asked to integrate 1 over x plus 2 to the power of 4. Now have a go at the question first yourself and then have a look at the video for the solution. So here we let u equals x plus 2. So differentiating both sides, we get du equals dx. So we can now substitute u for x plus 2 and du for dx. So we now integrate 1 over u to the power of 4. Now 1 over u to the power of 4 is the same as u to the power of minus 4. And when we integrate, we add 1 to the power and divide by the new power. So this becomes minus 1 over 3 u to the power of minus 3 plus c. So we resubstitute x plus 2 back into the equation for u. So we get minus 1 over 3 x plus 2 to the power of minus 3 plus c.